Welcome to another edition of the Henstitute. In this one, we're going to talk about relative intensity. And so here's what is a little bit different about relative intensity when you're talking about sound intensity. So what I have over here in my picture is what is called a Fletcher Munson set of curves. And if you think about sound, most people tend to think of how many decibels it happens to be. Now, the concept of decibels is actually kind of interesting because deci is a prefix, and the idea is deci is 1/110th of something, so 1/10th of something. And then bels is actually the true unit. And the idea was originally to come up with a relative scale that went from 0 to 10, where 0 is supposed to be the quietest sound you could hear, and this was supposed to be the loudest sound you could hear. So the idea is to come up with some kind of relative scale. 0 to 10 worked okay, and then eventually when they switched it over to decibels, basically what that did is that multiplied everything by a factor of 10. So this actually went from 0 to 100 to kind of make it similar to the Celsius scale. Now, the interesting thing is, based on these Fletcher Munson curves over here, is unfortunately the sound that you actually hear changes a little bit. So if you get lower frequencies, you actually need them to be higher in intensity. They need to get somewhere up here before you can actually hear them. If you notice, they have a little section on here, it's called the threshold of hearing. And the idea of the threshold of hearing is based off of at 1,000 hertz, what the 0 is. So notice over here we have an intensity level. This should actually be your relative intensity. So relative over here, and it changes a little bit. But if you kind of base it a little bit on 1,000 hertz, which is a kind of a fairly high pitch, but not too bad, we kind of go with our normal numbers. And if you notice, actually the highest is not 100, it's actually 120 up here. This is what's sometimes known as the threshold of pain. Threshold of pain. And that means that when you get up in that 120 hertz or 120 decibel range, it's going to be painful to actually listen to it. So it's not that it's too high of a pitch. That's like when something, screeches really high and you're like, oh, that's annoying. I'm talking about that is really loud that you have to cover your ears because it's just too much intensity, it's too much power going in. So the idea all kind of based off of this threshold of hearing, and the threshold of hearing actually has a absolute intensity. So the threshold of hearing is that it takes 1 times 10 to the negative 12 watts per square meter for you to actually hear something. So that's a pretty small number, but this is what we actually find that people need. So to find a relative intensity, typically what we do is we actually use this kind of number, and this is sometimes referred to as the I0. This is kind of the lowest intensity. Can you go lower than this? Of course, you can get 0 watts per square meter. That would actually be no sound power whatsoever, but we don't want that. We want the kind of the lowest. So relative is always based off of the average person. Now, obviously, some people can hear lower than the threshold of hearing. Some people need it louder before they can actually hear it. That's why these curves kind of vary. The frequency is dependent on it. We're just going to kind of base everything off of the 1,000 hertz scale. And so relative intensity, usually designated with a Greek letter beta here, so this relative intensity is the Greek letter beta, is actually, first it's going to be multiplied by 10. That was just to switch it over into decibels. It's actually a logarithmic scale, so it's actually the log to the base 10 of the absolute sound intensity of something. So this is your absolute sound intensity. And it's related to the threshold of hearing. So this is the number on the bottom. And when you put everything into this, you can actually calculate the relative intensity, and it will be in decibels. So it'll be in decibels. And when we're trying to find something, if you actually had something at the threshold of hearing, then I and I0 would both be the same. So you'd be taking the log to the base 10 of 1, and log to the base log of anything, any base of 1 is always 0. And so you would get a relative intensity of 0, which would be 0 decibels. If I happen to have something up here at my 100 or my 120 or these other scales, basically you're getting higher and higher intensities, and then you're taking the log to the base 10 of those numbers. So this is what we're actually going to use to find relative intensities if we want to measure things in decibels. So it's kind of neat. So we have this absolute intensity scale and this relative intensity scale, and this one's a relative because it's based off of the human ear. Hope you enjoyed this edition of the Henstitute, and we'll talk more later.